Hi students, we're going to start vodcast 2.2. We're going to talk about classifying matter. In our last video we talked a little bit about what matter was and talked a little bit about properties, and in this video we're going to talk about how we break down matter into different things. So first off, we've got pure substances. This is like when we break matter down, we've got pure substances and non-pure substances. So the word substance for us means that it's matter that has the same composition and properties. Okay? If it is a pure substance, that means that for whatever sample of that matter that we have, that it's all the same substance. So you don't have substance A and B in it, that everything in it's the same substance. So pure substances that you would know, purified water, oxygen, sugar, gold, any of those things that's all there is in it, that's what we would categorize as a pure substance. One of the biggest categories of pure substances for us are those of just elements. Elements are basically the simplest form of matter. We're going to talk a lot more about breaking that down here in a little bit. So how do you know if something's an element? Well, the simplest way is that if it's on the periodic table, then it's an element. This is a website called ptable.com. You can go to www.ptable.com. Great website, all kinds of information on it. And if something's on here, then it's an element, and therefore it's an element and a pure substance at the same time. And what I'm showing you here is that the periodic table, the shape of it, all that stuff down on the bottom actually goes in the middle. We'll talk a lot more about that when we get to electron configurations in a couple of weeks. But if it's on the periodic table, it has to be an element. We're going to talk real briefly about the symbols for elements, the symbology for it, because it's kind of important that you recognize what's an element and what is not. And aside from looking on the periodic table, because there's 116 or so elements, so you can't look at them all the time. So if we write like a capital F or a capital Cl, those are elements. That's fluorine and chlorine. You'll notice that in the chlorine, the C is capitalized, the L is lowercase. And that's always a hint that that is an individual element by itself. Okay, every element has a symbol that either has one capital letter or a capital letter followed by a lowercase letter. And sometimes they're not as obvious as others. That's why we're memorizing some of those. So let's talk about what that makes that different if we see a couple of different symbols. So in this case, I've got two things. They're both CO. The first one is capital C, capital O. The C in that one is carbon, but the O in it is oxygen. The capital letter lets me know that there's another element there. Okay, but if I look at the CO, big C, little o, that is an element. It's cobalt. Okay, and so it becomes really important that you know to put your uppercase letters and then a lowercase. Uppercase and lowercase matter a lot in chemistry. You can't mess that up. You can't write everything in lowercase. If you're someone that writes everything in uppercase, you're going to have to fix that. So the other kind of pure substances are what we call compounds. And this formula down here is the formula for a compound. That's sugar, okay, ordinary table sugar. And basically what a compound is it's a chemical combination where we have two or more elements joined together. It says here in a fixed proportion. That just means that it's always the same amounts. Okay, so in sugar it's always 12 carbons to 22 hydrogens to 11 oxygens. And so I'm going to break it down here. What the formula also tells us is how many atoms of each element are in that molecule. So we've got 12 of the C, which is carbon. We've got 22 of the hydrogen, okay, the H, which is hydrogen, and 11 of the O, which is oxygen. Remember that the numbers, the subscripts, they only correspond to the element that they're right next to. Okay, so that 22 just goes with hydrogen, the 12 just goes with carbon, the 11 just goes with oxygen. We'll see a little bit later on when we get to formulas, we can put the parentheses and stuff to show if there's more, like two of multiple things. And the important thing about compounds here for us is that compounds are chemically bonded together. This is different than the physical bonds that we're going to talk, or the physical combination that we're going to talk about in a little bit. They are chemically bonded. That means you have to do a chemical reaction to separate them. That is in contrast to what we have here, which are mixtures. And we're going to do a whole next vodcast is on mixtures. We're going to talk about different kinds of mixtures. But basically a mixture is where you've got two or more substances and they're mixed together, but they're not chemically bonded. And what that means is that it doesn't really change what each thing is. So like if I make some sweet tea, which is one of my favorite mixture examples, then the sugar is still sweet. It's still got its properties. The water is still liquid. The tea still has most of the same chemicals in it that it did before. So those things are mixed together and they're still retaining their own properties. I could isolate the sugar. I could boil off the tea and get the sugar back just like we did salt the other day. So here's the overall breakdown, and you probably want to stop. You hopefully have been pausing to get notes, but you probably want to pause here and write down this chart. So on the right-hand side of the chart, this is what we're really concerned with. We break matter into pure substances. Pure substances can be broken into elements and compounds. And then on the other side are mixtures, and we're going to talk a lot more about mixtures in the next vodcast, but you see that there's heterogeneous and homogeneous mixtures. And in the next vodcast, we'll talk a little bit about what that is. Here's what's really important for us also for mixtures, just to get some little real-world example of what we did. In all of our classes, we just did the separation lab. And what you did in the separation lab is that you separated a mixture. You had a mixture of 4 things that were physically combined, and we used physical methods to then isolate them. Okay, we filtered, we used density, we used a magnet, okay, and then we boiled off the water to get the salt crystallization back. All of those are physical methods, just like we did in lab. We didn't do any actual chemistry in the sense of we didn't do any chemical reactions. Everything was the same at the end of the reaction or the end of the lab as it was at the beginning. Thanks, guys.